Good evening. So guys, we are solving another Leetcode medium level problem. So let's move on and start by reading the question. You are given an array of integers nums and the head of the linked list. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. So here is our link. Here's our list, and in case the list item appears in the linked list, which is our head, we need to remove that from the linked list and return the head of that linked list. Let's read it again. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. Okay, seems that I've got the question, and let's start. So return value is equal to list node 0 head. So I'm doing this without thinking. This is a trick I learned recently in list manipulation problems. Adding a list item before the first linked list element lets us do the tricks that I believe we are going to use in this problem too. So we have this, and we need to check. We need to walk over the linked list and check if the value of the node is in nums. Is in nums, but this doesn't seem to be very efficient, but let's see if it works. So if it's in nums, let's read it again. Return the head of modified linked list after removing all nodes. So we need to remove something from the linked list that have value that exists. Yeah, so the condition should be in, not the opposite. So if the head value is in nums, we need to remove the current. So it can't be head. I believe it should be current. Current is equal to head. We need to preserve the original head. Therefore, we are assigning and we are moving this current and checking the value of the current. And if the current is in nums, then we need to do something. What we need to do is we need to remove list items. For example, if we want to remove these two, we need to change the value of next of the previous item. So next should be modified, and we need to skip the current and move the next to the next of the current. So that means we need preview, and here is where we are going to use this. So preview is equal to return value is equal to return value, and then we are going to modify the value of the preview, right? Preview is equal to return value, and initially it has to be equal to the to this dummy list element, and in fact we will return value next. Return value next. So let's start removing. So if it's in the nums, then the previous next should be changed to current next, and regardless of anything, we need to move current forward. Current is equal to current next. But if it's not to be removed, then we need to move previous to the current. previous is equal to current, I believe. So let's see if this is right. So if we go to, we on the first iteration, the current is 1, which has to be removed, because it's in the nums, right? So because it's in the nums, we need to have previous, and we actually have, it's not in on the picture, it's imagine a dummy element with a value of 0, which has to be the default value, with the value of 0 and next of head. So it points to this element, and this is head originally, right? So if current is to be removed, because the value is that have a value that exists in nums, the previous is next, which is now is equal to head, should be equal to the current's next, which is this thing here, and it represents current next at the first iteration. Otherwise, so let's see what happens here, right? So the previous is next is being moved here, current is being moved here, and now we need to remove again. That means that previous is next is again being moved here, and current is being moved here, and then we need to remove again. So previous is next is being moved here, and current also is being moved here, and previous is still this dummy value, right? The value of the previous didn't change to this moment. Then we don't need to remove the current, but we need to move current forward regardless of anything, because we need to check all the list elements, and therefore we need to move current. So this is correct in my opinion. So previous also needs to be moved, because we preserved the original head in this value, actually, which will never change, but we need to change this structure. So if we don't move the previous, and we end up having this situation where current is 5 and then previous is 4, I believe in this scenario it still will work. Yeah, it still will work, because we don't need to remove anything. So we do not modify any of next values, which is effectively modification of the list structure. So we don't need to touch any next value. We don't need to touch any next value like we do here, when we don't need to remove anything. So we are not doing this. So in this scenario, it will still work, I believe. I'm hesitant to check. Let's check the other scenario before we actually do the check. And we have another example as well. So previous is somewhere here out of the screen, current is here, we need to remove, previous is next, is being moved here. So we lose, and we move current here. So and garbage collector will remove this for us. So we now have something which is previous, and we have its next showing pointing to this 2, and we have current set here. But now we don't need to change, we don't need to remove this, and we need to move forward, right? Current is being moved forward anyways, because we need, just like I explained just now, because we need to check all the elements. So in this case, we need to move previous here for the next iteration, because when we need move the previous here and current here, and current is to be removed, in that case we surely need to modify the value of the previous is next, like we did here, and therefore we need to drag the previous behind the current for being able to modify next if that's needed. So that's needed for the scenarios where next of this is to be changed, right? So we stand here, and only then we will know that the next of these two is to be changed. If we don't move the previous pointer, it will still remain there, and we will lose information about this node preceding a node which has to be removed. So therefore, we need to drag previous behind the current. I believe this will work. Let's check. Yeah, it does. How is this special? I don't know. Let's submit. Takes too much time. I believe we will have the worst solution. Time limit exceeded. Okay, this means that we are doing something terribly inefficient. And let's see, let's try to estimate the complexity. So we have a list which is nums, which is this. Okay, so every time for each node we walk over all the elements in nums. I guess we can nums is equal to set nums. I believe this will not break anything, but this will convert the nums to the set. And how will this help is the access time for a known element in the set is equal to O1 instead of On. So we are reducing the complexity, computational complexity of this statement from On to O1. Let's check if we didn't break anything. We didn't, and let's submit to see if this solves our problem. Yeah, and it's not too bad, right? We are over 88% in runtime, and we are over 44% in memory. I'm not sure if there's a way to reduce the memory usage, but somehow. Okay, anyways, let me know if you have any ideas. How can we reduce memory usage? Of course, without sacrificing the computational complexity. Let me know in the comments if you have some good ideas. Yeah, we'll see you next time.